Hi guys, and welcome to another video. And in today's video lesson, we are going to be looking at trigonometry sketch exam question type 2. And the question that we're looking at is from the February-March 2010 paper 2. Question 10 reads as follows. Sine of 28 equals to A and cos of 32 equals to B. Determine the following in terms of A and or B. Cos 28, cos 64, and sine of 4 degrees. Now, this is called a sketch type question because we have to, in this case, draw two right angle triangles, and we have to now put A and B in these triangles. So let's see what we're going to do here. So let's look at the first one. Sine of 28 equals to A. So sine of 28 degrees equals to A over 1. Now remember that this is a ratio, and a ratio is a fraction. So firstly, write it as a fraction. Therefore, my right angle triangle is going to look as follows. So my reference angle is 28 degrees. Now remember that we'll complete the triangle. So the complement of 28, 90 minus 28 equals to 62 degrees. 62 degrees. What is sine? Remember, sine is opposite over hypotenuse. So therefore, the opposite side is going to equal to A. The hypotenuse is going to equal to 1. And the adjacent side will be, remember, using the theorem of Pythagoras, square root of 1 squared, which is 1 minus A squared. Let's draw our second diagram. Cos of 32 equals to B. Let's write that down. Cos of 32 degrees equals to, remember this is a ratio, so write it as a fraction. Cos of 32 equals to B over 1. What is cos? Remember the acronym SOHCAHTOA. So cos is adjacent over hypotenuse. Let's draw our right angle triangle. So that's going to be 32 degrees. And remember now, so that's my reference angle 32. So there's my opposite side here, but my adjacent side will be down here. So that'll be B adjacent over hypotenuse. Using the theorem of Pythagoras, the opposite side will equal to 1 squared, which is 1 minus B squared. So therefore, both triangles are completed. Let's just find the complement of 32. 90 minus 32 equals to 58 degrees. Now you can say that it is completed. Right, so both triangles are completed. So now we can answer our questions. Let's look at what they want here in 10.1.1. Cos of 28 degrees. So 10.1.1. Cos of 28 degrees. Let's go look for the triangle with 28 degrees. So looking at that, you can now see that 28 degrees is here, and that's my reference angle. And remember, cos now is adjacent over hypotenuse. So my adjacent side is the square root of 1 minus A squared, and the hypotenuse is equal to 1. So therefore, that's my solution. Will be the square root of 1 minus A squared over 1. So that's going to equal to square root of 1 minus A squared all over 1. So we can simply just write the square root of 1 minus A squared. And that's the first solution. Don't forget to show all the working and draw these diagrams in your solution. That's very important. Cos of 64 degrees. Let's go look at 64 degrees. How can we get 64 degrees in terms of the angles that we have? Now, 62, there's 28 there, but if you look here, 32. Remember that cos of 2 times 32. Remember cos of 2 times 32, if you look at it carefully, 32 times 2 will equals to 64. So what are they testing here? They're testing your knowledge of double angles. Alright? Because if you look here, they say cos of 64. What will cos of 64 be now? Cos of, so we can manipulate it, cos of 2 times 32 degrees. Now remember our cos expansions. So 10.1.2. So for double angles, let's look at cos of 2 alpha. Let's write that down. Cos 2 alpha. Cos 2 alpha equals to cos squared alpha minus sine squared alpha 2 cos squared alpha minus 1 minus 2 sine squared alpha. So firstly, what we're going to do is we're going to manipulate this angle. So we're going to write down here cos of 2 times 32 degrees. And now we can choose any one of these expansions. All right, you can choose any one of these expansions. The one that I will choose is that one there. So let's look at that. So therefore it'll be 2 cos squared 32 degrees minus 1, right? And if you choose A, so now if we look at cos of 32 degrees, so let's go back to our diagram. Cos of 32 is going to equal to, remember that's the opposite side, the adjacent, and that's the hypotenuse, so it'll be b over 1. So therefore we have 2b squared minus 1, right? 2 times, remember, b over 1 all squared will be b squared minus 1. That's our solution in terms of b. Let's look at the next one, 10.1.3. They're asking us here for sine of 4 degrees. Now 4 degrees. So if you look at it here, let's look at these angles. So what angles do we have? We've got 28 and we've got 62, we've got 32 and 58. How can we get sine of 4 degrees? If you look carefully, if we have to say 32 minus 28, that will give us 4 degrees. So what are they testing here? Well, they're testing compound angles. So it's important for us to know our theory. So for this particular question, sine of 4 degrees, that's going to equal to sine of 32 minus 28. And remember now our compound angle expansions. Sine of A minus B is equal to sine A cos B minus cos A sine B. So therefore, remember, know your theory well. Equals to, so we can say sine of 32 cos of 28 minus cos of 32 sine of 28. So what is sine of 32? Let's go look at here. So sine of 32 will be the opposite side, so it will be the square root of 1 minus b squared all over the hypotenuse, which is 1. So let's write that down. Square root of 1 minus b squared all over 1. But we don't have to write the over 1 part. Let's go look at the next one. Cos of 28. Cos of 28. Let's go look at that diagram. So cos of 28 will be, remember, that's the opposite. This is the opposite side. So the adjacent side will be square root of 1 minus a squared all over 1. So therefore here, square root of 1 minus a squared over 1. You can write it if you want to, but remember over 1 is itself. And now let's complete this. Cos of 32. Cos of 32 will be, remember, that's opposite, so it'll be adjacent over hypotenuse, so b over 1. So we'll write that as b, and sine of 28. Sine of 28 is the opposite over the hypotenuse, so a over 1 is a. So therefore, there's not much simplification that you can do from this point on, so we can leave our answer in that form. Learners, it's important for you to know your theory in these type of questions. If you haven't subscribed already, please subscribe to JL Maths. Also like my Facebook page adjusting Lazarus mathematics. Also, you can check out all the videos on jrmaths.com. And I'll catch you in the next video.